CEN ISO IEEE 11073 Health Informatics Medical Health Device Communication Standards enable communication between medical, healthcare and wellness devices and with external computer systems. They provide automatic and detailed electronic data capture of client-related and vital signs information, and of device operational data. Background goals: real-time plug-and-play interoperability for citizen-related medical, healthcare and wellness devices, efficient exchange of care device data acquired at the point of care in all care environments. Real-time means that data from multiple devices can be retrieved, time-correlated, and displayed or processed in fractions of a second. Plug-and-play means that all a user has to do is make the connection. The systems automatically detect, configure, and communicate without any other human interaction. Efficient exchange of care device data means that information that is captured at the point of care can be archived, retrieved, and processed by many different types of applications without extensive software and equipment support, and without needless loss of information. The standards are targeted at personal health and fitness devices and at continuing and acute care devices. They comprise a family of standards that can be layered together to provide connectivity optimized for the specific devices being interfaced. There are four main partitions to the standards: device data, including a nomenclature or terminology, optimized for vital signs information representation based on an object-oriented data model, and device specializations, general application services, internetworking and gateway standards, transports. Problems: in the absence of standards for these devices, data is captured either manually or at considerable expense, or it is not captured at all, which is most often the case. Manually captured data is labor-intensive, recorded infrequently, and prone to human error. Use of expensive custom connectivity equipment drives up the cost of care delivery, is only used for patients with the highest acuity, and tends to lock care providers into single companies or partnerships that provide complete information systems solutions, making it difficult to choose best-of-breed technologies to meet client needs, or the most cost-effective systems. Development and deployment of advanced care delivery systems are hindered. For example, systems that collect real-time data from multiple devices and use the information to detect safety problems, or to quickly determine a client's condition and automatically, or with minimal carer involvement, optimally adjust a device's operation cannot operate without these standards. With no standardization in this area, even when similar devices to provide communications, there is no consistency in the information and services that are provided, thus inhibiting the development of advanced care delivery systems or even consistent health records. In short, appropriate use of 11073 device communication standards can help deliver better health, fitness and care more quickly, safely, and at a lower cost. Motivation: these are the only standards addressing this area of connectivity. They provide a complete solution for medical device connectivity, starting at the physical cable or wireless connection up through the abstract representation of information and the services used for its management and exchange. They can enable full disclosure of device-mediated information, so measurement modalities be declared in detail and the associated metrics and AMP alerts communicated, together with any user-made changes to settings. In addition, the device can communicate its manufacturer, model, serial number, configuration, operating status and network location, all in real time if required. The IEEE 11073 standards have been developed with a high level of international participation. They have been, and continue to be, adopted as International Organization for Standardization Standards through ISO TC 215 Health Informatics and as European standards through the Committee for European Normalization TC 251 Health Informatics, specifically as the CEN ISO IEEE 11073 series. The end result is a single set of internationally harmonized standards that have been developed and adopted by ISO and CEN member countries. These CEN ISO IEEE 11073 standards have been developed in close coordination with other standards development organizations, including IEEE 802, IHTSDO, ERDA, HL7, DICOM, and CLSI. Memoranda of Understanding with IHE, IHTSDO, and HL7, and close liaison with Continua Health Alliance assists still wider integration. The CEN ISO IEEE 11073 nomenclature is now being used to populate and to establish equivalence within SNOMEDCT, the most widely used clinical terminology. A liaison between the IEEE 11073 standards group and the USA Food and Drug Administration Center for Devices and Radiological Health in the USA helps ensure that patient safety and efficacy concerns are fully addressed in the standards. The Continua Health Alliance and the English NHS National Programme for Information Technology both specify use of the standards for device communication. The standards have been included in the USA National Committee on Vital and Health Statistics recommendations to the Department of Health and Human Services related to patient medical record information message format supporting health insurance portability and Accountability Act compliant implementations. The cost of integrating innovative technologies into established product lines is reduced, and a barrier to new companies is lowered. Availability 11073 standards are available freely to those actively involved in the development. Others may purchase them. For published and draft standards, search for 11073 at IEEE ISO or CEN. Standards may be purchased from the National Standards Organization, a bookstore. Overview. The ISO IEEE 11073 medical health device communication standards are a family of ISO IEEE and CEN joint standards addressing the interoperability of medical devices. The ISO IEEE 11073 standard family defines parts of a system with which it is possible to exchange and evaluate vital signs data between different medical devices, as well as remote control these devices. Point-of-care medical device. The core standards are personal health device. ISO IEEE 11073 personal health device standards are a group of standards addressing the interoperability of personal health devices such as weighing scales, blood pressure monitors, blood glucose monitors, and the like. The standards draw upon earlier IEEE 11073 standards work, but differ from this earlier work due to an emphasis on devices for personal use in a simpler communications model. These are described in more detail at ISO IEEE 11073 Personal Health Data Standards Core Standard. Nomenclature. Within this standard, nomenclature codes are defined. These give the possibility to clearly identify objects and attributes in relation to the so-called OID code. The nomenclature is divided in partitions to demarcate codes with regards to content and functions. Programmatically, these codes are defined as constants. Those can be used by a pseudonym. Example in C++. Asterisk definition for the partition object infrastructure. Asterisk define the object simple medical device system. Asterisk domain information model. This standard is the heart of Vital. Within this, objects and their arrangement in a domain information model for vital signs data transmission are defined. Beyond this, the standard defines a service model for the standardized communication. Base standard, the common background for assembly and transmission of objects and their attributes are defined in this standard. It's subdivided in a communication model and an information model. The communication model describes the layers 5 to 7 of the OSI 7-layer model. The information model defines the modeling, formatting and the syntax for transmission coding of the objects. Agent-manager principle. All defined parts of this standard family are designed to allow communication according to this principle. The arrangement of two or more medical devices as a system, so that the components are possible to understand and to interact, are the basic idea of this principle. The agent is the part of the principle that is connected to the medical devices. It provides the data. The manager keeps a copy of the agent data, reacts on update events from them, and triggers events on the agent. In most use cases, the manager is only used to remotely monitor and display agent data, but in some cases it may also remotely control the agents. Agents and manager are built in the same structure. This enables an agent to act as a manager and reverse. Besides the plain agent-manager application, hybrid systems over multiple stages are possible. Agent application process. This module is the interface between a proprietary protocol and the ISO/IEEE object world. It is not defined within the standard and as a result it can be implemented free. Medical Data Information Base. MMOs are stored hierarchically within a tree structure in a form named Domain Information Model. This MMOs and their arrangement in the DIM are defined within this standard. The implementation of the MDIB and the functionality is out of the scope of the standard. Association Service Control Element. This module is subject to the standards ISO IEC 15953 and ISO IEC 15954. It has services available that controlling the association assembly and disassembly. A possible association and their condition is negotiated here. No MMOs are transmitted over this module. Common Medical Device Information Service Element services for the data exchange of MMOs between agent-manager systems are defined in this module. This data exchange is highly dynamic. Objects are created, changed or deleted by services named create, update, delete, through reports, which can be defined detailed down to the single object attribute. It is possible to trigger complex operations in agent or manager through this services. Presentation layer. This layer contains the encoding of object data. Objects, groups of objects, attributes or single attributes are encoded by SN. 1 representations, respectively. The specialization MDER session layer. That layer controls connection at the session level. Domain Information Model. The central core of the standard is the so-called Domain Information Model. Objects containing vital sign data representations and the relationships are defined in this model. Objects for additional services around vital signs data objects are defined also here. For content-sensitive classification of the objects, they are divided into packages. Medical package, the package that defines objects to map medical vital signs data. There are different objects to store vital signs data in different ways. As an example, the real-time sample array object for the management of EEG, ECG data be mentioned. Alert package. This small package is related within the medical package. It is used for setting and administrating alert parameters to objects from the medical package. System package. A representation of a medical device can be achieved with objects of this package. It contains concrete derivations of the abstract MDS object. One of these concrete derivations are ever the root object of a DIM tree. The battery object and the clock object are further objects in this package. The last one can be used for time synchronization of medical device data. Control package. Inside the control package, objects for the remote control of a medical device are defined. There are objects used for influencing the modality of measuring and objects for direct remote control of medical devices. Extended services package other than the name supposes. In this package, essential and never used objects are defined. This package is built on called scanner objects in different derivations. Scanning data and other objects and generation of event reports who can be sendent is the sense of this objects. The scanner objects have a wide range of different attributes for a wide range of applications of the DIM. As an example, the FastPeric scanner object is specially constructed for the requirements of real-time data exchange in conjunction with the real-time sample array object to transmit live data from EGC devices. Communication package. The objects in these package contain information which are responsible for basic communication profiles. These packages are developed very open, so that different communication profiles and interfaces to proprietary device interfaces can be built. Annotation by the author. From a historic view, the standard was developed for the first time in the early 90s. This package has to be reconstructed. Archival package. Storing patient-related data in online or offline archives is the idea for objects in the archival package. For example, the patient archive object can store vital signs data, demographic data and treatment data in one object. Patient package. The patient package contains only one object, the patient demographics object. This object contains patient-related data and can be set in relationship to an MDS object or one of the objects from the archive package, to give anonymous data the reference to patient data. Communication model. The complete communication sequence can be very complex. This article should provide basic information that can be described in more detail at a later time in a separate article. Finite state machine. The finite state machine regulates the synchronization of an agent manager system over different conditions. A complete session round trip starts up with the disconnected state, is transferred by multiple stages to the initialized state, in what the actual data transfer shall be done, and ends with the disconnected state. Initializing MDIB. During the association phase, the configuring state will be reached. In this condition, agent and manager are to exchange object data for the first time. In the process, a MDSCREATE event in the form of a report will be triggered. This report creates a copy of the MDS root object from the agent MDIB in the manager MDIB. Afterward, a context scanner object is created in the agent MDIB. This scanner object scans the complete MDIB and generates a report containing the complete agent MDIB representation, except the MDS root object. The manager evaluates this report and creates the objects defined here in his own MDIB copy. At this point, the manager has an exact copy of the agent MDIB. Both are now at configured state. Data exchange through services. The Common Medical Device Information Service element provides a GET service to deliver data requested by the manager. The agent GET service retrieves a list of attribute IDs. These IDs identify explicit values within agent's MDIB. Now the agent creates a report containing the requested values. This report is sent back to the manager. Data exchange through scanner objects. In an MDIB, additional objects shall be created through the create service of CEN ISO. The manager requests the agent through this service to create a scanner object itself, and to fix the scanner object on one or more values. Optional, for example, the scan interval for the data delivery can be set. The agent creates the scanner object in his own MDIB and sends the manager a response message. Now the manager creates a copy of the scanner object in his MDIB. The data updates from agent to manager now occur automatically through the scanner object. Through CEN ISO's delete service, the scanner object can be deleted, like all other MDIB objects.